This is hands-on friction. This lab is a very quick and easy way to observe friction, and it is a fun little party trick. So for this lab, what you'll need is a meter stick. So what I've done is I've put a table up of where we're gonna start our left finger and right finger when we're gonna do this lab. So the first placement is I place my left finger on the 0 mark and my right finger on the 100 centimeter mark. And what I do is I slowly pull my fingers together. I move both of my hands, right? I slowly move my fingers together. So when I started at the 0 mark and the 100 mark, it ends at the 50 centimeter mark. So that's what I'm gonna put in that last column on the table of where my fingers met. So I'm gonna repeat this experiment, except I'm gonna place my fingers at different points along that meter stick. Now, one thing that I want you to observe while doing this, if you move your fingers slow enough, you'll notice that only one finger is sliding at a time. The other is stationary. So while I'm moving my fingers together, only one is sliding across the ruler and one is stationary, and they alternate until my fingers met in the middle. And what you should have gathered is that it does not matter where I place my fingers originally on this ruler, they're always going to meet in the middle. Even on the extremes, like if I place my left finger on the 45 centimeter mark and my right finger on the 100 mark, well, it doesn't matter, right? Notice that my right hand is sliding, 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 and then eventually, yeah, they trade off, and then they're gonna meet in the middle. Now, if you recall, friction depends on two things: the nature and condition of surfaces and how hard those surfaces are pressed together. So as we're sliding our fingers together, we are changing one of those variables. Now, nature and condition of surfaces, that's just what the surfaces are made out of and the conditions of the surface. Now, we aren't changing that as we're sliding our fingers together. I'm not changing the conditions of my finger or the meter stick, right? It's the same surfaces. What I'm changing is how hard those surfaces are pressed together, and you can really feel this when you place your left finger on the 45 and your right finger on the 100. You feel that there's a lot more weight of that meter stick pushing down on your left finger than on the right finger. So where your fingers are placed affects how hard those surfaces are pressed together. Now let's take a look at the phenomenon of only one finger moving at a time, right? As I pull both my fingers together, only one finger is sliding on the ruler at a time. They seem to trade off. Now here's why. So if we look at the graph for friction, the force required to start an object sliding is going to be more than the force required to keep that object sliding. So as your fingers get closer to the center of that meter stick, more of the meter stick is pushing down on it. There's a larger normal force. Those surfaces are being pressed together harder, and it takes a larger static frictional force to start your finger sliding on the meter stick. So what's happening is your fingers are basically trading off. One is static, right? One is static and one is moving. Now what happens is as that finger that's sliding moves closer and closer to the center, that kinetic friction force is increasing, and once that kinetic friction force is larger than the static friction force on the other side, they trade off, right? So now this finger is sliding, and once that kinetic friction force gets larger than the static friction, it starts the other finger moving. So that's why if you do this slow enough, only one finger is moving. Now the reason why I call it kind of a party trick is because you don't have to do this with a meter stick where you're measuring. This works with anything that has like a uniform surface. You could do this with a simple pencil, right? A simple wooden pencil. So you put your fingers on either end and you slide them together, and notice, yep, still same effect. They're trading off until what they're going to do is your fingers are going to meet at the center of mass of that object. So once again, this is hands-on friction.